Good morning, everyone. My name is Saicharan Aram, and today I'm excited to present a deep dive into an exciting topic in natural language processing, image captioning with connecting vision and language. This topic is especially fascinating because it combines computer vision and natural language processing to help machines see and describe images just like humans do. The impact of this technology is far-reaching, from social media automation to assist visually impaired users. Let's explore how image captioning works, the challenge it faces, and the advancements that are shaping in its future. Introduction to image captioning. To start with basics, what exactly is image captioning? Simply put, it's AI-driven process that takes an image as an input and generates a meaningful textual description. Why is it important? Humans naturally describe images with words, but for computers, this is incredibly complex. It requires both vision and language understanding, making it one of the most challenging tasks in artificial intelligence. Example, if you look at the picture on the right side of the slide, a dog playing in the park. If we give this image to AI, the caption should be generated as a golden retriever is running through a grassy field with a ball in its mouth. It may look simple, but the thing is, the model must recognize objects like dog, ball, grass, and the actions like running and the relationships dog playing with the ball in the field. Sounds easy for us, but it's massive computational challenge. Coming to the next slide, importance of image captioning. This technology is more than just a cool AI trick. It has real world applications that impact millions of people every day. Such as accessibility, helps visually impaired users understand image content using text-to-speech systems. Screen readers can read, describe images in web pages and social media posts. Image search and retrieval. Google Photos and Instagram allow users to search images using text like sunset at the beach without manually tagging images. AI assistants and automation. In the modern world, virtual assistants play a key role, like Siri and Alexa can describe images, helping users interact with the content hands-free. Self-driving cars and surveillance. In the modern world, autonomous systems interpret surroundings using real-time image captioning. For example, we all use Google Lens to scan an object and get a description. That's image captioning in action. Coming to the next slide, how does the image captioning works? Now there are two components in this process: feature extraction by using computer vision and caption generation by using natural language processing. Coming to the feature extraction, it uses convolution neural networks to extract visual features from an image, identifies objects, backgrounds, colors, and spatial relationships. Coming to the caption generation, it uses recurrent neural networks, also known as RNNs, and algorithms such as LSTMs or transformers to form meaningful text from the features extracted from the computer vision. Maps extracted features into grammatically correct captions. If you look at the basic workflow, how does it work? We give input image to a system. It applies convolution neural networks and do the feature extraction on that particular image, and then does the sequence modeling by using LSTM, and then at last the final caption would be generated. For example, if you see an AI sees a cat on the couch, it generates the caption such as a fluffy cat is resting on a grey couch. If you properly look at the caption here, it is objectifying everything in a proper manner. It describing this how does the cat looks and what is the position of the cat and on what object the cat is sitting and what is the color of the background. So that how detailed this caption generation works. Coming to the next slide, complexities in image captioning. Even with modern AI, image captioning is far from perfect. Let's look at some major challenges. One of the major challenges is visual ambiguity. A single image can have multiple correct options depending on the context. For example, an image of a dog with a bone. It can be considered into multiple aspects. A dog chewing a bone or a hungry dog holding a bone. Coming to data bias, AI models inherit biases from their training data. Example, if a dataset has more images of men playing sports than women, captions might reinforce gender stereotypes. Linguistic coherence. Ensuring captions are grammatically correct and contextually relevant is still a challenge. Real-time processing. Uh, Generating captions instantly is computationally expensive, making it tough for live applications such as Instagram Live or YouTube Live. If you can consider any kind of live streaming imaging tool where it requires a caption generation. Coming to the next slide, the data sets used for image captioning. If you see, to train AI models for image captioning, we need large data sets. Some of the most widely used ones are Microsoft Common Objects in Context, Flickr 8K, Visual Genome, and Conceptual Captions. If you go in detail, Microsoft Common Objects in Context contains 330K images, each with 5 different captions, and it is considered as gold standard for benchmarking models. Coming to Flickr 8K and Flickr 30K, Flickr 8K has 8,000 images and Flickr 30K has 30,000 images, each labeled with multiple captions. Coming to Visual Genome, provides detailed object relationships and region-based descriptions. Conceptual Captions, it's owned by Google. It has over 3 million images with high quality AI-generated captions. So why are only these models are considered and why these are important? Providing diverse image text pairs to improve model accuracy and help train AI models for real world natural language processing. So these are the some techniques used in image captioning. So before deep learning, there are the traditional models, and after the advent of deep learning, as we discussed in the feature extraction, it uses CNN, and RNN is used by natural language processing, and algorithm is LSTM, and we also use encoder decode for framework and attention mechanism. We'll go everything in detail. Over the years, several models have developed to improve image captioning accuracy. One of the earliest models, Show and Tell, 2015, as we discussed earlier, introduction to encoder-decoder architecture using CNNs for feature extraction and RNNs for sentence regeneration, just like we discussed in the second slide. The Show, Attend and Tell model improved upon by this adding attention mechanism, allowing the model to focus on specific parts of an image while generating captions. Another key model is Neural Image Caption Generator, also called as NIC, further refined this process by enhancing language translation through LSTMs. In 2018, bottom-up and top-down attention introduced, object detection before caption generation, improving caption accuracy. More recently, transformer-based models such as Image GPT and Visual Transformers have significantly advanced the field, producing captions with superior context awareness and fluency. Coming to the next slide, real-world applications of image captioning. Image captioning has widespread applications across various industries. In healthcare, AI-generated image descriptions helps doctors analyze X-rays, MRIs, and other medical scans by providing textual summaries. For accessibility, screen readers use image captions to assist visually impaired users in understanding digital context. In e-commerce and social media, platforms like Instagram and Amazon automatically generate captions for product images and improving searchability and user engagement. Another key application is in autonomous systems such as self-driving cars, where image captioning helps interpret traffic signs and detect obstacles. Additionally, AI-powered search engines use image captions to improve indexing and retrieval, making it easier to search for image using in the text queries. Coming to the next slide. Any AI model, any or particularly any algorithm need to have an evaluation metrics to check its proper capacity. Here we have evaluation metrics for image captioning. To assess the quality of the captions generated by AI models, various metrics are used, such as BLEU, bilingual evaluation understudy score, measures the similarity between generated captions and the human rated references using n-gram precision. And next one is generated captions, Meteor, metric for evaluation of translation with explicit ordering, considering synonyms, stemming, and word order, providing a more flexible accuracy measure. And the third one is Rogue, recall oriented understudy for gisting evaluation, compares text overlap, often used for summarization tasks. Meanwhile, each metric provides a different perspective on caption quality, and models are often assessed using a combination of these methods to ensure robust evaluation. Coming to the next slide, overcoming hurdles in image captioning, which were discussed in the earlier slides. Despite significant progress, image captioning still faces major challenges. Caption ambiguity is a primary issue. One image can have multiple valid descriptions depending on context. Another challenge is the need for diverse training data, as models trained on limited datasets may struggle with the real-world variability. Bias in AI models is another concern, where training on unbiased dataset can result in captions that reflect cultural or gender biases, as we discussed in the earlier slides. Additionally, understanding abstract concepts remain difficult for AI, as images depict emotions or artistic scenes require deeper contextual comprehension. Finally, real-time caption generation is computationally expensive, limiting its use in live applications. Addressing these hurdles require continuous improvements in datasets, model architecture, and computational efficiency. And coming to the next slide, what are the possible advancements in AI models for image captioning? Recent advancements in AI have greatly improved image captioning performance. Transformer-based models such as Vision Transformer, and GPT-4 have set new benchmarks in accuracy by better understanding and contextual relationships. A combination of CNNs, computational neural network, and recurrent neural network remains widely used, leveraging deeply for both image processing and sentence generation. Multimodal models like CLIP and BLIP enhance image captioning by integrating visual and textual data. Additionally, self-supervising learning techniques are reducing reliance on large labeled datasets, making training more scalable. Large language models, such as called as LLMs like GPT-4, are also being incorporated to generate more coherent and contextually relevant captions. These innovations are pushing the boundaries of image captioning, making it more precise and useful across various applications. And coming to the next slide, ethical considerations in image captioning. Ethics play a crucial role in AI-based image captioning. One major concern is datasets bias, as we discussed in the earlier slide, where training data may reflect social stereotypes, leading to biased or misleading captions. Ensuring fairness and representation is vital to prevent discrimination in AI-generated descriptions. Privacy concerns are another issue. AI models must be designed to avoid exposing sensitive or personally identifiable information from images. Additionally, misinformation risks arise when AI generates incorrect or misleading captions, which can have serious consequences in fields like journalism and healthcare. To mitigate these risks, researchers are working on diversifying datasets, implementing ethical AI frameworks, and developing bias detection mechanisms to ensure fairness and accuracy across all the generated textual descriptions. Coming to the next slide, frameworks and tools used for image captioning. We'll broadly discuss the major tools that are currently in the industry, which are widely used for the image captioning. Developers use various frameworks and tools to build and deploy image captioning models. TensorFlow and PyTorch are the most widely used deep learning frameworks, providing extensive libraries for model development. Cloud-based AI solutions such as Google Cloud Vision and AWS Recognition offer pre-built captioning services for businesses. Transformer models like those for Hugging Face enable pre-trained captioning capabilities that can be fine-tuned for specific applications. Attention-based architectures further improve caption accuracy by allowing models to focus on important regions for an image. Additionally, multimodal AI frameworks combine vision and language processing, enhancing caption generation quality and contextual understanding. Coming to the next slide, what are the future possible trends in image captioning? The future of image captioning is driven by advancements in multimodal AI, where models integrate both vision and language to produce more accurate descriptions. Self-supervised learning is reduced dependence on large-based datasets, making training more efficient. Context awareness improvements are allowing models to understand scenes more holistically, resulting in richer and more meaningful captions. Emerging trends also focus on real-time caption generation, enabling faster and more interactive AI experiences. Additionally, artificial intelligence is moving towards personalized captioning, where models generate descriptions tailored to a user preferences or needs. These innovations will continue to enhance the accuracy, usability, and scalability of image captioning technology. Finally, we came to challenges and research areas. While image captioning has become a long way, several challenges remain unheard or unanswered. Fine-grained captioning, which involves generating highly detailed descriptions, is difficult to achieve. Understanding complex object relationships with an image is another challenge. As artificial intelligence struggles to capture nuanced spatial and contextual information, cultural and linguistic adaptations is an important area of research. Captions must be tailored to different languages and cultures while maintaining accuracy. Bias mitigation continues to be a critical focus to ensure fairness and inclusiveness in AI-generated captions. Lastly, improving real-time performance is a key goal, as reducing latency is an essential for applications in live environments such as augmented reality and robotics. Coming to the key takeaways, in summary, image captioning bridges the gap between visual and language, enabling AI to generate meaningful textual descriptions from images. Deep learning advancements, particularly in CNNs, RNNs, LSTMs, and transformers, has significantly improved caption quality. Ethical considerations remain a challenge, requiring careful dataset curation and bias detection strategies. The future of image captioning lies in the multimodal AI, self-supervised learning, and real-time applications, ensuring more accurate and personalized captions across different industries. Uh, Coming to Q&A, as we conclude, I'd like to open the floor for discussion. What do you think is the most exciting development in image captioning? Do you believe AI-generated captions are accurate enough for real-world use? Lastly, as AI evolves, how can we ensure responsible and unbiased image captioning? Let's discuss. Thanks for giving me this opportunity. Thank you so much.